Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International A-Level Chemistry, Unit 2 for June 2022. I will do this paper in three parts. There will be a part 1, a part 2, and a part 3, comprising of the three different sections of the paper, and I'll put the links to part 2 and the part 3 video below the description box of this video. Let's begin. Question 1 says, which equation represents the standard enthalpy change of formation, dF theta, H theta, for aluminum oxide? We can see, remember, standard enthalpy change of formation is when 1 mole of, in this case, aluminum oxide is formed from its elements in their standard state. We can see this one here, we can see this is all aluminum element, but we can see this is not oxygen element, that is not oxygen element, so B and D are out. However, this is an element and that is an element. But when we look at the product side, this is forming 2 moles. Here, that is forming 1 mole. So the answer should be 1 mole of aluminum oxide formed from its elements in their standard state. So the answer should be an A, as we can see here. So question 2 says, how does an oxidizing agent change during a redox reaction? Remember, an oxidizing agent is something that gets reduced. So if something gets reduced, its oxidation number decreases. And remember, reduction is gain of electrons, so the oxidizing agent gets reduced because it gains electrons and the oxidation number decreases. So the answer to question 2 is an A, as we can see. The next question says, which of these compounds would be expected to have the highest boiling temperature? To know the highest boiling temperature, we have to look at which functional groups are present, what is the molar mass. I tried to roughly calculate the molar mass and I found this one to be 72, 72, 74, 74. So in terms of molar mass, these ones are going to have more electrons and a higher possibility of having more London forces. However, when we look at this is branched in comparison to this. Both of them do have OH groups, so they have the possibility of formation of intermolecular hydrogen bonds. So the one that is unbranched, having the same chance of formation of intermolecular hydrogen bonds, yet having the highest overall molar mass, in comparison to the others, is going to be the B. So B is correct. Remember, B and A have the same molar mass, but A is highly branched, meaning it will have fewer London forces in comparison to B. So question 3, the answer should be a B. Let's move on. Question 4 says, what is the name of the compound which forms what's the name of the compound with the formula KClO2? Here we have to find the oxidation state of chlorine in this compound. So let's assume you know potassium is always a 1, chlorine, if it's an X, oxygen in this case is going to be -2. -2 times 2 gives you -4. Combining this, and remember this is a compound, total oxidation should be 0. So here it comes out to be X is equal to 3. So the oxidation state of chlorine in here is a +3. Therefore, the compound should be potassium chlorate 3. The answer should be a B. Quite easy. Question 5 says, a small piece of calcium is added to a beaker of distilled water, as we can see here. Then they ask, which is the equation for this reaction? Remember, calcium is added to distilled water. This is not steam, liquid water. The equation for the reaction should be a D because when metals react with water, they produce alkali. In this case, calcium should produce an alkali plus hydrogen. So the answer here should be a D based on the equation we can see here. This is going to be wrong. Metals reacting with water do not produce oxides. Wrong. This could be okay, but remember this is not the correct formula for calcium hydroxide. So the only answer here should be a D. Question 5b says, which element is oxidized and which is reduced when calcium reacts with water? Reaction of calcium with water, calcium becomes oxidized. I wrote an equation here, as we can see. Calcium is going to change the oxidation state from 0 to +2, while in the water, hydrogen is going to change from +1 to 0. Therefore, hydrogen becomes reduced, while calcium becomes oxidized. So the correct answer here is calcium oxidized, hydrogen reduced. The answer is an A. And question 6 says here, which is the ionic equation for the reaction of barium carbonate with dilute hydrochloric acid? Barium carbonate is a metal carbonate. When they react with acid, they produce salt, carbon dioxide, and water, as we can see here. However, to break it down into an ionic equation, I tried to separate all the aqueous, leave the solid alone, only break apart the aqueous. So barium sulfide will remain as it was, but this is aqueous, so I'll break it down into 2H plus and 2Cl minus. On the other side, barium chloride is soluble, so it should be Ba2 plus 2Cl minus, and the rest, gas and liquid, remain unchanged. So we see it's only the chloride that cancels out on either side. Therefore, the answer to question 6 should be an A. Let's move on to question 7. Question 7 says the presence of ammonium ions in a compound can be shown by adding a reagent, warming with the mixture and testing the gas evolved. Remember, ammonium ions, the reagent added is sodium hydroxide, and then the gas tested is ammonia gas. We test ammonia gas using damp red litmus paper. So here, they say the reagent is sodium hydroxide, and here the gas tested should be using a damp red litmus paper when it turns blue. And again, this one you have to remember from memory. This is your topic 8. This is very easy if you remember all these experiments. Here, the answer should be a D. Question 8 says, aqueous chlorine is added to an aqueous solution of potassium iodide. A nonpolar organic solvent is then added, and the mixture is shaken. The layers are allowed to separate. I want to demonstrate this. Remember, we have aqueous chlorine added, so we have potassium hydroxide, potassium iodide. To this, when we add chlorine aqueous, now you know a displacement reaction is going to occur between chlorine and potassium iodide. Since chlorine is more reactive than iodine, it is going to replace iodide in the potassium iodide, and the reaction that is going to occur is as you see here. Potassium iodide reacts with chlorine, producing potassium chloride and iodine. So it means the iodine is free in the aqueous solution, and when you add a nonpolar organic solvent, this iodine is going to be more soluble in the nonpolar organic solvent. And everybody knows iodine in an organic solvent forms a purple color, and here the closest was violet, so violet had to be the answer, which is D. Let's move on to question 9. Question 9 says, a titration is carried out by adding dilute sulfuric acid from a burette to aqueous sodium hydroxide in a conical flask. The indicator is methyl orange. What is the color change of the indicator at the end of this titration? So we know that at the end of this titration, of course, it's going to be turning from yellow to orange. Remember, again, here you are using methyl orange indicator, and the aqueous sodium hydroxide is going to be in here. So you have methyl orange. And we have sulfuric acid is going to be here, H2SO4. Of course, the indicator will change from yellow to orange towards the end of the titration. So the answer here should be, what we see here, the answer should be a C. And yeah, that's it. Moving on to question B says, a student carried out the first titration and did not notice that there was an air bubble between the tap and the tip of the burette. During the titration, the air bubble filled with acid. And again, you guys should see that most of my papers, I try to write as much explanation as possible. Even the explanations I'm not going to say, I write them on the paper so that as you guys read, you can be able to have extra explanation. So here when they said during the titration, the air bubble filled with acid, it means some of the space that was the air bubble contained was filled by volume, so the student records more volume used for the burette. So they think they have used more volume, yet actually they have used less, but there was an air bubble that had to be displaced or replaced. So moving on, the student then carried out 2 accurate titrations in which there was no air bubble and in the burette. There was no other errors in these titrations. Which of these could be the 3 titers for the student? Now here, remember to use, if there is no error carried out, it means the second titer and the third titer have to be concordant. So when we look at this one here, the second and third are the same, but because they're the same as the first, yet there was an error in the first, A cannot be the correct answer because all are the same. Now when we come to B, we can see this is kind of higher, but you can see this and this are not concordant because the difference between them is 0.9. Therefore, 2 and 3 cannot be B cannot be the answer. Coming to C, yes, we can see this is higher. That and that are concordant because the difference between them is 0.05. So C makes sense. Coming to D, we can see 22.80 under 23. This is supposed to be higher than any of these. Since this is lower, that should have been perfectly carried out a higher. That cannot be the answer. So the only correct answer here is a C because it makes sense. The next part says, 25 centimeters cubed of 0.1 mole per decimeter cubed aqueous sodium hydroxide required a mean titer of 18.7 centimeters cubed of sulfuric acid. They have given us the equation for the reaction, and they say, what is the concentration in mole per decimeter cubed of sulfuric acid? We are looking for the concentration of this, yet we have this information. So I began by calculating the number of moles, which is this concentration times that volume. Remember, the volume has to be converted in decimeters cubed, so I divided by 1,000. When I multiply 0.1 times 25 over 1,000, I get 2.5 times 10 power negative 3 mole. So using the equation 2 to 1, it means the moles of this should be half the moles of sodium hydroxide. So moles of sulfuric acid should be a half times the mole of sodium hydroxide, which gives me that. And finally, the concentration of this should be number of moles over volume, which is this number of moles divided by the volume used, and it gives me 0.0668 mole per decimeter cubed, whereby B comes out to be the correct answer. Let's move on to question 10. Question 10, hydrogen peroxide decomposes as shown. So here we have the equation for the decomposition. And then they say a catalyst increases the rate of decomposition by catalysts create an alternative pathway with lower activation energy. So anytime you talk about a catalyst, you have to talk about activation energy and not necessarily kinetic energy. So that and that are out. So it leaves a C and a D. Here they say increases activation energy. No, it decreases activation energy. So the correct answer here should be a D. It is more appropriate compared to the other answers. Question B says a bar of hydrogen peroxide is leveled 10 volume. This means that 1 centimeters cubed of hydrogen peroxide solution decomposes to produce 10 centimeters cubed of oxygen at room temperature and pressure. What is the concentration of 10 volume of hydrogen peroxide in mole per decimeter cube? So here you had to begin by knowing what 10 volume is. Remember, they have said 10 volume, it means 1 centimeter, produces 10 centimeters cubed of oxygen. So 1 centimeter cubed hydrogen peroxide, it will produce 10 centimeters cubed of oxygen. So I began off by looking at the concentration. Remember, they are looking for concentration in mole per decimeter cubed, meaning the total volume should be 1 decimeter cube. So since we call the concentration 10 volume because 1 centimeter produces 10 centimeters cubed of oxygen, how about 1 decimeter cubed of hydrogen peroxide? How much oxygen will it produce? So remember, 1 decimeter cubed is 1,000 centimeters cubed. So I came here and I said, if 1 centimeter of this produces 10 centimeters cubed of that is the concentration we call 10 volume. So for 10 volume, let me just write it like this, 10 volume. 1 centimeter cube of hydrogen peroxide produces 10 centimeters cube of oxygen. If we want to know how much concentration in mole per decimeter cubed, it means the volume of this should be 1 decimeter cubed, which is 1,000 centimeters cubed. How concentrated is this going to be? So here I said we use the ratio. Remember, 1 creates 10, so it means 1,000 centimeters cubed should create 10 times 1,000, which is 10,000 centimeters cubed. So I came down here and I said, so 10,000 centimeters cubed, that is going to be the volume of gas produced. And since we know there is this equation, number of moles is equal to volume of gas divided by molar volume. 10 centimeters cubed of oxygen divided by the 240,000 creates the number of moles of oxygen that could be produced from 1 decimeter cubed of hydrogen peroxide. And it should be 0.416667 mole. Now, I know the number of moles of oxygen that should be produced from 1 decimeter cubed of hydrogen peroxide. Now, I'm going to use this number of moles and my equation to predict back the moles of hydrogen peroxide that could have been used. Remember, based on the equation, we have a ratio of 1 to 2. So it means the number of moles of hydrogen peroxide should be twice the number of moles of oxygen produced. That is why you say this. 2 times that creates 0.833333 moles, and therefore 1 decimeter cubed of hydrogen peroxide contains 0.83333 mole. So the concentration is 0.8333 mole per decimeter cube. The answer comes out to be a D. The key thing was knowing that the concentration they were looking for is mole per decimeter cubed. Therefore, the volume of hydrogen peroxide should be 1 decimeter cubed. If you can understand that, and also know that the volume of the solution they had was 10 volume. Imagine you have 10 volume, that is the concentration. Concentration is equal to 10 volume, and the volume you have here is 1 decimeter cubed. What will be the concentration of this? If you can work with that, then it's going to be there. Concentration of this in a mole per decimeter cubed. We will use this volume here, and knowing that one of these creates 10 of the other, match up, find the number of moles of oxygen, and then work backwards to find the concentration, like I've shown in my expression here. If you didn't understand, please look carefully at the page I'm showing you here, because it will make it easier for you to understand fully. So I am going to delete this and then leave some space and move on to the next page. Let's continue. Here, question 11 says, a mixture of hydrogen and iodine is left in a sealed container at 300 degrees Celsius until equilibrium is established. And again, remember, this is a reversible reaction, as we can see. So they say the equilibrium mixture is then cooled and the color of the mixture darkens. Remember, iodine the dark color is due to iodine. Hydrogen has no specific color. Hydrogen iodide, no specific color. Darkening is due to iodine. So here, when they say the equilibrium mixture is cooled and the color of the mixture darkens, it means cooling causes equilibrium to go towards the side, or to be inclined towards the side where iodine is going to be produced, meaning this side is going to be an exothermic reaction, and therefore the forward reaction should be endothermic. So here they say which is correct. Change in position of equilibrium should be to the left, because darkening is due to production of iodine, and the forward reaction should be endothermic because cooling caused equilibrium to be shifted to the backward, meaning the backward reaction is actually exothermic. Moving on to question 12, they say, the structure of ethylene amine is as shown here. Which type of reagent will attack the partially positive carbon atom? The partially positive carbon atom is attacked by a nucleophile, because remember, this carbon is partially positive because it's it has kind of lost its electron, so it has to be attacked by something that is good at donating electrons. That should be an electron-rich species, which is a nucleophile. So the answer for that should be a C. Moving on to the next part. Which of these alcohols will produce a carboxylic acid when heated under a flux with acidified potassium dichromate 6? Remember, acidified potassium dichromate 6 only oxidizes primary alcohols to convert them into carboxylic acids. If a secondary alcohol is oxidized, it will produce a ketone and not a carboxylic acid. Primary alcohols go through aldehydes and then carboxylic acid. So let's see, this is a primary alcohol, so that is primary, it can be, this is secondary, it cannot be, and that is tertiary, it cannot be. So the answer should be only this one and this one, because they are the only primary alcohols, meaning our answer here should be a B. Moving on to question 14, it says, two reactions of cyclohexanol are shown. This is cyclohexanol going through two reactions, one in this direction and the other to the other direction. Question 1 asks, what is the reagent for reaction 1? Reaction 1 is converting an alcohol into an alkene. That is a dehydration reaction. Water has to be removed, so phosphoric acid has to be used as the drying agent, or as the catalyst in this case actually. So it should be concentrated phosphoric acid. That is what is going to be used. So question 14, the answer should be a C. 14A, so moving on, 14B says, the reagent for reaction 2 is acidified potassium dichromate 6. Here they ask which equation best represents the reaction. Again, I want to take you back. Reaction 2 is oxidation conversion of an alcohol into, this is a ketone. So to form a ketone, this is a secondary alcohol forming a ketone. That should be oxidation, and we know it's acidified potassium dichromate 6. The perfect equation is this one here. That is wrong because you're producing hydrogen, and they should be an oxidizing agent this side. So that and that are wrong. This one here is wrong because they're using oxygen, not the oxidizing agent. In chemistry, we can represent an oxidizing agent in those square brackets. So C is the only correct answer. Lastly, here we see this is cyclohexanol and cyclohexene. Each has a peak in their infrared spectrum, which is not present for are the compounds. Which are these peaks? We have to know, if you use the data booklet, we have to know that carbon-carbon double bond should be missing in the cyclohexanol, while the OH bond should be missing in cyclohexene. Remember, cyclohexene will have a carbon-carbon double bond, but will not have OH. And the cyclohexanol will have OH, but no carbon-carbon double bond. So we can see that this here is going to be, the peak only in cyclohexanol is going to be this because of the OH. And the peak here in cyclohexane is going to be a carbon-carbon double bond due to this one here. So the answer should be a C. To be able to answer part C here of question 14, you have to refer to your data booklet and look for where these two bonds, or these two carbon-carbon double bond and OH double bond, look for the wave numbers of those in order for you to predict which answer should be correct, but it should be a C. So this brings us to the end of this video, which is the section A of the June 2022 Unit 2 chemistry paper. Please do not forget to subscribe to our channel. See you in our next video. Bye-bye.